I always videotape it. That way if anybody's absent, they still can take notes. Yeah. All right. So multiplying and dividing. This first example is multiplying. And multiplying is almost exactly the same as simplifying. It just adds an extra fraction to deal with. And the reason it's almost identical is because if you guys remember how to multiply fractions, if you had, let's say for instance, if you had like 1/2 times 3/4, you just multiply straight across. So 1/2 times 3/4 would be 1 times 3 over 2 times 4, and you would get 3/8. So having two fractions next to each other makes things a little bit more complicated, but for us, for this unit, it doesn't change things a ton. It just makes it so that you're doing like two problems in one. That's all it really does. So for us, let's go ahead and try an example that is a Math 3 level example, which this one was not. So for the Math 3 version, instead of seeing something that's like x squared minus 3x minus 10 over x squared plus 8x plus 15, this is something that could have been on your warm-up, right? Just one fraction. Today, we're going to say, okay, let's take that one fraction and let's multiply it by another fraction. X squared plus 2x minus 15 over x squared plus 9x plus 14. But the steps are the same. So just like we did yesterday, we're going to factor, we're going to cancel. The parentheses that are left over on the top go on the top. The parentheses that are left over on the bottom go on the bottom. That's it. It works exactly the same. You just have two fractions instead of one. And if I had three fractions next to each other, then it would work exactly the same. We would just have three fractions instead of two. Okay? So we're going to start factoring these. So we're going to say, okay, what multiplies to negative 10 but adds to negative 3? What multiplies to 15 but adds to 8? What multiplies to negative 15 but adds to 2? What multiplies to 14 but adds to 9? So we have to find all of those so that we can properly do the problem. So I know this one is 5 and 3. Anyone know any of the other ones? Seven and 2. Which one is 7 and 2? Oh, 14. Negative 5 and 2. Multiplies to negative 15, adds to 2. Anyone know what it should be? 5, negative 3. Perfect. Okay. So now we just have to put our parentheses here. So x minus 5, x plus 2, x plus 5, x plus 3, x plus 5, x minus 3, x plus 7, x plus 2. Okay. Wait for just 1 second. So just like yesterday, we're still canceling the parentheses that are identical, and we're still canceling one parenthesis on the bottom with one parenthesis on the top, and they don't have to be in the same fraction. They can be like across. Wait until I'm done with this example. Okay. So this x plus 2 can cancel with this x plus 2. That's what makes today a little different, is because we have two fractions, the canceling doesn't have to be in the same fraction. So we're going to say these two cancel. What else do you guys see that could cancel? X plus 5. And then it looks like that's it, because everything else is not identical. So we've got more parentheses left over than we did yesterday, but that's correct. So we're going to have x minus 5, x minus 3 left over on top, x plus 3, x plus 7 left over on bottom. And if you wanted to, you could FOIL the top out, you could FOIL the bottom out, but you don't need to. It would be unnecessary. And so this is our final answer. That's all you got to do. So we're still factoring and canceling like we did yesterday. It's just a little bit more factoring. How your brains feel? Yeah, real similar to yesterday. Okay, let's try another one. So here we're going to do k squared minus 2k minus 3, k squared minus 4k minus 5, k squared plus 8k plus 7, k squared plus 4k minus 21. So tell me what the numbers are for each of these. Negative 3 and 1. Negative 5 and 1. 7 and 1. Negative 3. Okay. So if we write this out, we have k minus 3, k plus 1. K minus 5, k plus 1. K plus 7, k plus 1, k plus 7, k minus 3, and then what cancels? K plus 1. So you can either do these two k plus 1s or you can do these two. You cannot cancel the top two because it has to be a top and a bottom. Can't be two tops. And you only get 1 and 1. So do you guys want to cancel these two? Or do you want to cancel these two? Nope. It won't make any difference in the long run. Okay. What else do we want to cancel? K plus 7. Okay. What else do we want to cancel? K minus 3. Okay. So what's our final answer? K plus 1 over K minus 5. Perfect. Okay. How do we feel about multiplying? Multiplying is good? Okay. Dividing adds just a little bit more to it, but not much. Okay, so if we were going back to, anyone remember when you guys learned how to divide? When did you guys learn how to divide, or fraction specifically? When was that? Was that middle school sometime?
Yeah, I think about 6th grade, 5th or 6th grade.
5th or 6th grade? Okay. Do you guys remember how they taught you to divide? It wouldn't have been go, because go across is... Uh-huh. Yeah. So some of them do kind of cross multiply like that, which students kind of get confused because then they don't remember which one goes on the top. And then some teachers teach keep it, change it, flip it. Does that sound familiar? So we're going to do keep it, change it, flip it. So keep the first fraction the same. Change the middle sign to a multiplication problem. So change it from a division to a multiplication problem. And then flip the second fraction. Yeah. Reminds you of Kentucky Fried Chicken, but not quite. All right, so then if we do that, keep it, change it, flip it, then we can multiply straight across. So 1 times 4 is 4, 2 times 3 is 6, and then every so often we'll end up with the problem that we should be reducing. So we have 4 over 6, and that does reduce. What does that reduce to? 2/3. That reduces to 2/3. Okay. Perfect. Okay. So 2/3 would have been the answer for this one. So let's go ahead and do a Math 3 version of the problem. All right, so we're going to write down the Math 3 version. The Math 3 version is, let's write it. X squared minus 1 over 4x divided by x squared minus 5x plus 4 over x cubed minus 16x. Give me 1 second. I'm just going to end this real quick. There we go. Okay. So before we even get started, what should we do? Should remind you of Kentucky Fried Chicken. Keep it, change it, flip it. So we're going to keep the first fraction the same. We're going to change it to a multiplication problem instead. And we're going to flip the other fraction. So whenever we see a division problem, we always are going to do that. And then after that, then it just becomes like the other problems: we factor, we cancel. Okay, so it just adds one little step. And then it's like normal. How do we factor x squared minus 1? It's not GCF, but it only has two terms. Yeah, x plus 1, x minus 1. This is a difference of squares problem. X plus 1, x minus 1. Okay, and then that is going to be over 4x, because this is a monomial. It's just one term, monomial, which means it doesn't get factored. It just stays like that. So it's going to stay just like that. Okay. Over here, we've got this part. We've got a GCF we can take out of the top. Can anyone see what the GCF is? Between x to the third and 16x. What could we take out? Anybody know? We can take out an x, and then what would be left over? X squared. 16x, we took out an x. Negative 16. And then, do you guys notice anything interesting about this? X squared minus 16. X squared minus 16. Does that make you think of anything? Is it done like that? Should it stay like that? Does the number 16 make you think of anything? Does the fact that it's x squared make you think of anything? Square root? Is 16 a perfect square? So if 16 is a perfect square, we got x squared is a perfect square. Should we write this as 2 parentheses? One with a plus, one with a minus. X plus 4, x minus 4. Okay, so that's what it should be instead of this. So that one could keep factoring. Okay, so the top is all factored now, and then for the bottom, we have to look at what multiplies to 14 and adds to negative 5. What multiplies to 14 but adds to negative 5? Negative 7 and 2. So x minus 7, x plus 2. Oh, that's gross. Does nothing cancel out? Oh, I typoed. Sorry, that's my bad. Whew. That should have been just a 4, not a 14. My bad, guys. I wrote it perfectly up here, and then when I wrote it down here, I wrote it wrong. I was like, nothing cancels out. Why? Why is this problem so terrible? Okay, so we're actually multiplying to 4 and adding to negative 5. It's going to make the problem much better. So what would multiply to 4 and add to negative 5? Yeah, negative 4 and negative 1. Okay, x minus 4, x minus 1. Okay, so can we see what cancels? X minus, you said x minus 1, x minus 4, and then there's one more thing that cancels. Yeah, just the x. The plane X cancels. So this plane X right here and this plane X right here. It leaves the 4 behind, but you can cancel just the X. Okay, so what do we have left over on top? 2 parentheses. X plus 1, X plus 4. What do we have left over on the bottom? 4. Can we cancel these 4s? Nope, that would kill a puppy. Can't do that. Okay. Perfect, just like this. Okay, do you guys want to see another multiplication example, or do you feel like you're okay? You're good? Okay. You guys feel okay? You guys feel good? Yeah? Okay, so the plan for you guys is we have the around the room activity. You can start, you can work in pairs, you can work in triples, you can start on any card you want. You're going to write down the problem on the card, and then once you get the answer to that problem, that answer is going to be on another card somewhere. And then you'll do that card next. So you will not be doing them in alphabetical order. Okay? So we're just going to start working on it, and then towards the end of the period, tell me how many you got done. I will put the cards online. My guess is we'll work on this today and tomorrow. But I will put the cards online too, so that if you want to do some at home, you could. So we'll see how many we get done. I might ask you guys to do a couple at home just to keep us going. But we'll see what we end up doing. Okay? So pick somebody to work with or choose to work alone. It's fine either way. And then go ahead and get started. Isaiah, you need to bring me your phone so you can focus a little bit more. Nobody looks at the floor every 3 seconds. You know there's no rule that says don't text except for Isaiah's brother and mama.
No, it was my mom and my baby brother. She just had it.
Oh, okay. Thank you.